Hello everyone. Today I'm going to talk about the current impact of dry root rot on chickpea production and its impact on the protein source at the dining table for a common person. And we're also going to talk about the potential impact of dry root rot. So first, going to talk about the plant chickpea, which is the most widely grown pulse in India, and it is mainly available in two significantly different varieties, Kabuli and Desi varieties, as you can see here. And it is consumed in three major forms: either whole grain, or split grain, or gram, also known as chana dal. And it is also chana dal is then can be ground into a flour, which is also known as besan. These are the three major ways in which it is consumed, and it is also one of the most widely consumed pulse in India. There are major reasons why chickpea is a major protein source for a common man. Its protein content compared to other pulses is lowest, slightly lower. However, the PDCA score, which is the protein digestibility score, is actually the highest among other pulses. This basically means that after cooking, this protein in chickpea is much easily assimilable and digestible compared to other protein sources. And chickpea is also a very good source of many minerals such as magnesium and phosphorus, potassium, and some vitamins as well. Furthermore, India is also the largest producer of chickpea. So, out of the total production, India contributes to around 61% of the total chickpea production in the world. However, chickpea production currently is facing a major issue from dry root rot disease. It is caused by a fungus called Rhizoctonia bataticola. And here you can see a healthy plant of chickpea along with an infected plant, and you can see that the damage is quite severe and the yield is completely lost. A major issue with the dry root rot disease is that it is significantly dependent on root water content, that is uh, drought spells or soil moisture content, and temperature. So as moisture content in the soil reduces, disease severity goes up, and at the same time, if temperature also increases, disease severity goes up, as you can even see here. So a healthy chickpea plant, and if it's only infected by the pathogen Rhizoctonia, it shows low infection. But in the presence of drought and high temperature, disease severity as well as incidence increases. So the number of plants infected also increases, as well as the severity of the disease increases. So as far as the current impact is concerned, here we can see two separate fields. So we can see a pathogen only field, and we can see a few infected plants. Uh, and most of the plants are actually healthy. So, but at the same time, if you look at the lower field, which is both drought and pathogen infected, we can see in almost entire the almost entire field is infected, and the almost entire yield is gone. In terms of the current impact, in most fields, disease incidence of up to 40% has been reported, and yield loss in combined stress fields has been reported between 50 to 70%, whereas in only drought stress fields, yield loss has been reported in up to 40%. So, of course, uh, in combined stress fields, yield loss is very significant in the fields where Rhizoctonia is infecting chickpea. This is the current impact of the disease. And also, in terms of seed quality, some plants do escape the diseases and they will not show infection symptoms, but it is possible that the grain quality reduces in such fields because they're already under drought and pathogen inoculum. So the grain yield or the grain quality can be affected for the consumer. The protein quality will reduce, quantity will reduce, palatability can reduce, sprouting can reduce, and also the gram flour, which is one of the most highly consumed form of chickpea in India. we will get lower quality of gram flour. It will also impact the farmer because the farmer keeps some seeds for the next season, and for the next season it will have those seeds will can have lower germination and viability, low quality, and also it will have soil inoculum. The pathogen will has reported to being seed borne, so such seeds can be infected, and in the next season as well, the new crop will have been infected. Furthermore, these seeds cannot get exported because foreign countries do not accept infected seeds. So this will directly uh, impact export as well as within our own country. If seeds are transferred to other fields, DRR can easily spread. And this is a map that shows the major top producing chickpea producing states in India. Uh, and this is a map that shows the drought affected states. So there's a strong correlation, as we can see that most of the states that produce high amounts of chickpea are also under drought. So this is annual data, and if you look at these blue pins, these denote the places where major DRR incidence has been reported. Again, there's a very strong correlation between drought and DRR incidence. We can see that the majorly drought affected states have higher DRR incidence or DRR reports. Furthermore, this is the temperature trend that has been for the last 50 years, and we can see that the trend is actually increasing. This can potentially impact dry root rot incidence and severity in the future. And as we will see in the next few slides, that the situation isn't improving, and DRR incidence could become much severe in the future. So this is precipitation because chickpea is mainly rain fed in India. It's very low, less number of fields are irrigated. So it's directly chickpea production is directly correlated to annual precipitation. We can see whichever year precipitation was very low, chickpea production was also affected. The issue here is that as we know that dry root rot can significantly increase yield loss in addition to drought. So whichever year we have low precipitation, it will cause more droughts, and which will cause more DRR incidents and significant higher yield losses compared to only drought. And coming to the export and import of chickpea, as I've already told you that India is the largest producer and consumer of chickpea, yet it is also the largest importer of chickpea. So even though we have a lot of chickpea, there is still a demand gap because to feed the population. And if dry root rot becomes a potential disease, it could affect the market price and it could affect the common man. India is also importing high, as you can see that import trend is also increasing, but this is mainly due to Kabuli varieties. So India exports mostly Kabuli varieties, whereas it imports Desi varieties because India mostly consumes Desi varieties instead of Kabuli varieties. So in terms of Desi varieties, there is still a demand gap, supply demand gap, which is filled currently via imports. And if dry root rot becomes a severe disease in the future, it this gap could widen, which could not only affect the market price but will also affect the protein source at the table. So if you look at the last 50 years of drought data and we correlate it, it can easily be correlated to chickpea production. As we see, the major drought spells are correlated to low chickpea production. And as I said, that potential yield losses could be much higher in the combined stress fields. And of course, drought and yield losses are directly correlated to market price. As we can see, the year in 2016, yield loss was majorly affected by drought, and it also affected the market price, which directly affects affordability of chickpea for the common man. Here we have the projected change using some models. These scientists they uh, predicted the change in temperature. In the top graph, we can see actually drought extent. So the projected drought extent expansion in the next 50 years in India. So if this scenario is observed, we can assume that dry root rot will become a major disease, as dry root rot is directly affected by drought. And in the lower graph, we can see temperatures. These are different models, and in every model, we see a rise in temperature in the next 100 years. So as temperature and drought both are correlated to each other, along with dry root rot, it could increase the severity of dry root rot in the future, which would directly affect chickpea production as well as protein source for a common man. In conclusion, uh, drought and temperature affect chickpea production. It lowers chickpea production, we know that, and it also increases the market prices. You can see a trend in market price increase. There's current data that supports this, and which affects affordability for the common man. However, if an increasing trend of drought and temperature continues, dry root rot will definitely become a major disease, which will significantly even lower yields, which would again significantly increase market price and affect the affordability and also the quality of greens that come to the dining table for the common man. So that's why research in dry root rot is required, so that we can combat this disease and be prepared for the future. Thank you.